Alright, so this video is on the factor and remainder theorems, and both of these theorems are going to show us why we have been learning synthetic division and how it's important to understanding our polynomial. Okay, so the remainder and the factor theorem are going to help us to find zeros, also known as x-intercepts. Okay, we know from graphing quadratics how important it is to find these zeros or x-intercepts. And then it's also just going to help us to find other points along the graph to help us to graph it. Okay, so let's go ahead and look at these. All right, so the remainder theorem is the first one. It says if your polynomial p of x is divided by x minus c, then the remainder is the same as if you evaluated the polynomial at c. Okay, so if we divide a polynomial, for example, by x minus 4, our remainder is going to be equal to if we just put 4 in for x in the polynomial and evaluate it. Okay, so let's look at an example. Okay, the example says, use the remainder theorem to evaluate the following function at x equals -2. Okay, so without the remainder theorem, we would go ahead, we would put -2 in for all of the x's and evaluate. Okay, but what the remainder theorem says is if we just take this polynomial and divide by -2 using synthetic division. Oh dear. Okay, so 3, 8, 5, and -7. And we don't have any missing terms here, so we don't need any zeros. All right, and I'm just going to set up my division bars here. Okay, and we're dividing by -2. So from all that practice on synthetic division, we know we bring down the 3. 3 times 2 is -6. 8 plus -6 is 2. 2 times -2 is -4. And then we add and multiply and add, and this is our remainder. Okay, and so we now know that if we substituted in all of these -2's and evaluated and simplified, we would find out that f of -2 is equal to -9. Okay, this is one way to write our answer. The other way is to write it as an ordered pair. Okay, where this is our x value and this is our y value. So we would know if we were graphing this, this would be a point on our graph. Okay, so whenever you're asked to use the remainder theorem, you're just going to divide using synthetic division, find your remainder, but you want to remember to write your answer one of these ways. Okay, and I have 6 practice problems for you to try, which I guess is kind of a lot, but okay, and so for each one of these, for number 39, for example, you're going to use synthetic division, divide by -1, and you're going to write your answer as p of -1 equals whatever your remainder is when you use division. Okay, so go ahead and try these. You can pause this video and you can check your answers on Classroom. When you're done, move on to the next slide. Okay, the factor theorem is the other important theorem that shows how useful synthetic division can be, and it says that c is a 0 if and only if x minus c is a factor. And what that means is you want to use synthetic division and it should divide evenly. It should be a factor. Oops, synthetic division, and it's going to divide easily. We should have a 0 remainder. Okay, so in this example it says show that x minus 2 and x plus 3 are factors of the given polynomial. 2x to the 4th plus 7x cubed minus 4x squared minus 27 minus 18. Okay, so I'm going to set up my synthetic division. I'm going to first divide by +2. Whenever we're using synthetic division, we use the opposite sign. Okay, and then I'm just going to go ahead and do the synthetic division. Okay, and as we see, we get a 0 remainder. Okay, so that means that x minus 2 is a factor of the polynomial. Okay, and then I'm just going to do the same thing again for the other factor. So I'll start with these. Same numbers. Set up my division bars. And we're going to divide by -3 this time because we always divide by the opposite sign. All right, so okay, and once again, 0 remainder. So we know that x plus 3 is a factor. And what is also important here is that when we have a 0 remainder, we know from the remainder theorem that that means that this is an x-intercept, right? This goes through the point 2, 0. That is a point on our graph. It also goes through -3, 0. Okay, so these are both x-intercepts, which we know is really important when we go to graph. All right, so I have 3 problems for you to try. You're going to show that each of these are factors of the given polynomial. Okay, you're going to use synthetic division, in this first case with 1. Set up all of your coefficients and divide and show that your remainder is 0. You're going to do that for all 3. You can check your answers on Classroom.